I use cross multiplication, or am I going to have to use a new method with the least common denominator? So Gary, what do you think? Is a cross multiplication going to work in this problem? No. Why not? Like over on this, the left side of the equation has two separate expressions. One's a fraction, one's not, but still it's not just one single fraction on that side. So we cannot use cross multiplication. So this is where this is a new idea. You can label your notes LCD. This is where we start to talk about, well, we can get a least common denominator. And there's two totally different methods for teaching this one. I'm going to follow the way that your book does it. If you, after the end of today, are like, you know, I find that it works better for me to do something a little different, there are other ways to do it. What the book does is says, find your least common denominator first, and then multiply everything by the least common denominator. Because what that's going to do is cancel out some of the denominators that are there. You're going to see what it looks like. So first of all, decide what your least common denominator is by looking at every fraction's denominator. Well, this 1 is really 1 over 1. And so that factor doesn't matter. The factor of 1 times anything is the anything. But x minus 5 is definitely one of our factors we have to consider. And so is the x. And so my least common denominator is going to be both of those put together, x times x minus 5. And then what I'm going to do is multiply this entire fraction. So I'm going to write it again just for the example's sake so it doesn't get messed up. And I'm going to take everything in this fraction and multiply by x times x minus 5. What that means is when I take x times x minus 5 multiplied by 1, I have x times x minus 5. When I take x times x minus 5 multiplied by this negative 8, what happens is, look at, I would have an 8, an x, and x minus 5, but I have an x minus 5 on the bottom. I'm going to write out all the work for this first one so that you can see what it looks like. So notice my least common denominator that I chose, I multiply it into the top. What happens here, though, that's very nice, is that the denominators cancel out. And, oh, I forgot my negative sign, or subtract. And then on the right side of the equation, keep going with this multiplying. It's going to be 3 times the x minus 5 all over x. And what cancels out there are the x's. Why is that nice? Look at my problem. Do I have any fractions anymore at all? All the denominators canceled out. And so now I just have x times x minus 5 minus 8 times x, yeah, because the x minus 5 canceled, and 3 times x minus 5. And I have an equation I can solve that does not have all those fractions and denominators, doesn't have fractions anymore, basically. Okay, before I go further, does that first step I did make sense with the multiplying by the x times x minus 5? Yes, okay. So from here, it's solving an equation. Distribute when you can, so we get x squared minus 5x minus 8x equals 3x minus 15. And then what you'll notice with a lot of these problems is they do end up with an x squared in them, so they're going to be quadratics. What does that mean we need to do if we want to solve it? Do we try to get the x alone, or do we try to set equal to 0? Those are really our only two different methods we've used in solving. Am I going to be able to get this x alone? No, I've got a whole bunch. I've got some x's, I've got some x squared, so we need to set equal to 0 and solve like a quadratic. So I'm going to take the 3x and bring it over here with these other x's. So I've got negative 5x, negative 8x, and negative 3x, so that's negative 16x. And then I'm going to add the 15 as well. And so now I have the equation x squared minus 16x plus 15 equals 0. And I can solve that by factoring because it's a quadratic equation. So x times x, 15 times 1 would give me the 15. And if I made them both negative, negative 15 and negative 1, it would add to the negative 16. So that means my solutions are x equals 15 and x equals 1. So in this case, both of those are solutions to this equation. Okay. All right, let's look at another one.